Today we're talking about graphing with transformations, and this is a topic we've covered in a previous chapter, so I've already filled out a lot of the details here just to kind of speed up the recording, and it might look familiar to you. So what we have here are what we call the parent functions. We're just representing it in function notation, and you could use the letter y to represent the output, that's fine. But that's one change that you'll notice from having written this down in a previous chapter, as well as the critical values or the key points that we are using. For most of them, they're the same inputs. We're using inputs of -2 through +2, but with the square root, we're not, because you cannot take the square root of a negative number. And we're not using every integer here because we want to be able to do this without a calculator, so that's why we're using inputs of 0, 1, 4, and 9. Same with the cubed roots. We're just selecting inputs that we can take the cube of by ourselves without using the calculator. So capture that if you need and jot that down, but let's take a look at this section right below it here. Here we're taking a look at this template, and I'm using the quadratic just to kind of represent everything that we might be encountering. You'll notice we have the letter A and a B, H and a K, and so we're talking about what each of these do to the shape of the equation. And these are the details themselves. So when you find the letter A, you're looking to see if it's positive or negative. And if it's negative, we're going to reflect it over the x-axis. And there's a little example of where you might find that. But A is also indicating a vertical stretch or a shrink. So if that is bigger than 1, it's growing taller. And if it's less than 1, then it's shrinking by that multiplier. B, on the other hand, this is a little bit tricky. B has to be inside the grouping symbols. However, it has to be separate from the x. So x still has to be positive. So if I were to have a negative x, I would factor out the -1, so the negative would be parked here. It's still inside the bigger grouping symbols. It's still being squared. But you'll see some examples on the next page where we're going to put that negative sign outside of another pair of grouping symbols so that the x and the h are by themselves, separate from the b. That is a side-to-side reflection, so it's over the y-axis. It's also going to affect your horizontal stretch and shrink, but it's not the value of b, it's going to be 1 over b. So it's the reciprocal of b that determines how the horizontal width changes. So for example, if you have y equals 3x squared, quantity squared, that's your value of b. b is 3, right? So we're saying b is 3. But that does not mean it's 3 times wider. To determine the horizontal stretch or shrink, you have to consider it as 1 over b. So we think of it as 1/3. That means the width will be shrinking, and it'll be 1/3 of the original width. So the A and B kind of play a double role. Either it's going to be a reflection, or it's going to be a stretch or shrink, or a combination of both. And the H and the K we've, again, dealt with before. H is your horizontal translation, but that's the one that's kind of tricky. This is the one where you have to do the opposite sign. So if you see a negative H, like a negative sign in front of that number, then you're actually moving it to the right. So in this example where you see the x minus 3, that's not left 3, that's a right 3. If you see a plus H like this, x plus 3, you have to think in your head the opposite sign. In other words, you have to think leftward movement of 3 spaces. Your value of k then is your up and down movement. So if it's a plus value, so positive 3, that means you're moving up, and if it's a negative value, that means you're moving down. So it makes better sense with the k. The sign indicates the direction. But with the h, it's the opposite of the sign that indicates the direction. All right, let's take a look at a couple of examples. What we're doing is really just identifying the parent function here. They're all the same parent function. And then just kind of verbally describing what the change is and then writing the equation itself. So in the lighter print, that's the parent function. This is our x to the power of 3 function. And when you're looking at that parent function, what you want to do is identify that inflection point. You always want to reference the point at the origin because then it has 0 and 0 for both the x and the y. It's easier to identify features off of the origin point. So even though they are pointing out, hey, this point over here is at 1, 1, we're not using 1, 1. We're using 0, 0. And then as we're taking a look at the resulting graph, this is how it's moved. You want to look at that inflection point. So again, that inflection point is where it kind of pauses for a moment before it continues upwards. So we have an increasing function. It almost looks like it stops increasing right there at the origin, but no, it keeps on increasing beyond the origin. So that's my inflection point. So all you're looking to see is, where's my inflection point now? And it's obviously just moved down 1 space. So if the parent function is y equals x cubed, then we want to write this as x cubed minus 1. That's the value of k that we are identifying there. That's the vertical movement. Here in problem number 2, here's the inflection point on the parent function. Again, it's at the origin. And we're looking at the inflection point. And you can see that we've just moved it to the right 1 space. So that's a value of h. So as we set this up, we want to think of it as x, and then something with the h inside the grouping symbols to the power of 3. We're moving it to the right one. You would think that's a positive one, but no, you always change the sign on the h, so it looks like an x minus 1 in the grouping symbols. So that's the value of h, indicating a rightward movement of 1. And then lastly, here's our parent function again. Again, there's your inflection point at the origin. So where is it now? We've moved left 2 and up 1. So we have both h and k. So I would write my function as x and then some value of h quantity cubed. So again, as I'm going left 2, you want to change the sign and think of that as a positive 2. And then we're going up 1, so for the value of k, that'll be a plus 1. So there's your h and k values. So you'll have some homework problems like that, where you're just reading off of a given graph and describing how it changes. On to the next page. Here we are looking at an equation instead of a graph, and we're still trying to describe what is the parent function. Do we see any reflection, stretch, or translate? So let's do a few of those. Here in problem number 4, you can see we have a 1/4 x squared plus 2. So for the parent function, you're looking for any sort of exponent or any sort of grouping symbol, like the square root is a grouping symbol in number 7. Here we have the power of 2. There's no grouping symbol, so that implies the parentheses are only about the x. So that 1/4 is an a right in front of it, and there's a k in the back. So parent function is x squared. There's no reflection because there's no negative sign. We do have a stretch or shrink. This is a 1/4, which is less than 1. So describe it as a vertical shrink, because we now have to consider both A and B to know if we have a vertical and horizontal change. So vertical shrink, and describe how much of a vertical shrink. It's 1/4. The translation is our h and k values, and we have a k of 2, so that'll be up 2. So there's just a quick list describing what we have. Now if you contrast that with number 5, again, our parent function is x squared. This time you can see that the grouping symbols are now surrounding that 3, so that's my h. So we still have no reflection. Our stretch or shrink is still the same. That's the same value of a, which is the 1/4. So again, a vertical shrink of 1/4. And lastly, the translation, we're moving not right 3, but left 3. So always change the sign. That plus 3 in your head, think of that as a negative 3 to indicate a leftward movement. And then lastly here, that's actually your k in front. So if you don't like that, you can rewrite this and have the negative x squared up front and the plus 1 in the back. So there's your a, and there's your k. So again, my parent function is still the quadratic. Here we do have a reflection. It's sitting here. Again, it's not a b because it's not inside the grouping symbols. There's no grouping symbol, so that communicates the power of 2 is just on the x. So we have a reflection upside down, so it will be over the x-axis. No stretch or shrink. And lastly, for our translation, we're moving up 1. So those are fairly standard problems. The next row, these are not so standard. We have some problems here we're taking a look at, and this is where we have issues with the value of b. So that's what we're kind of talking about in this section. Our parent function is the square root of x. So we want to identify the reflection, the stretch, and the translation. First of all, this is not really in the right format. We want to shuffle it around so that my x is in front and the 2 is in back, right? That's a positive 2, so there it is. Now we said that on our template, we have to have that negative sign, which is representing the b, separate from the x. You want to make it look like you have a positive x in there, and just factor out the negative 1 outside. So we're going to create another set of brackets inside the square root symbol. So factor out a negative 1, and so now you have a positive x and a negative 2. So remember that the square root symbol is in itself a type of grouping symbol. So yes, this is a value of b, the negative 1 is a b, and the h is inside the parentheses as well. So we do have a reflection, and because it's on the b, inside the grouping symbols, not outside. We're not flipping it upside down, we're flipping it side to side. So it'll go rightward to leftward, so it'll be over the y-axis. No stretch or shrink here. We do have a translation. Take this negative 2 and in your head change that to a positive 2, so we're moving to the right 2 spaces. Contrast that with number 8. Here you can see the negative sign is outside the grouping symbols. So again, that's a value of a, and that positive 3 is also outside the grouping symbol, so that's a value of k. So again, parent function is square root of x. We have a reflection upside down, so this will be over the x-axis. No stretch or shrink, and we're moving up 3. So you can see the difference between the negative sign on the a and on the b. So to illustrate the negative sign on the value of b again, we have one more setup for you here on number 9. So you can see here's the a on the outside, there's the k on the outside, and we have this radical which is providing the grouping symbols, and we have a negative on the x. We don't want a negative x, we want a positive x. So we're going to reformat that so that we have a negative 1 factored away from the x and the positive 4. So now we have an a, we have a b, we have an h, and we have a k. So again, my parent function is the square root of x. With the reflection now we have negative signs in both a and b. So that means we're doing a double reflection, both vertically and horizontally. So that means it's going to be reflecting over both axes, so both x and y-axis. Stretch or shrink, the b is just a 1, the a is a 1/4. So once again we have a vertical shrink of 1/4. And lastly, for the translation, the value of h, you see that's a +4, but in our head change that to a -4. That corresponds with the leftward movement, so left 4 and then down 2. So in each of these cases we've been using some of the standard parent functions we've studied in the past. We've had our quadratic and we've had our square root. So when you look at example 10 now, you'll discover that this function is not a standard parent function. It's really a piecewise function, so it looks like a series of zigzag lines. So when we are using the notation f of x, we're just describing this is the graph. So we're not giving the individual equations to construct a piecewise function. This is sort of a shortcut saying there's some formulas out there. Let's just say this is the result of the graphing those formulas. It's the function. So what we're really doing is we're taking a look at how to interpret the function notation. How does this graph move, either with a reflection or a stretch or a translation based on the notation itself? So let's describe each of these in turn. So remember, if you are outside of this f of x, well then that would be where you find the a and the k. If you're inside the grouping symbols, that's where you would find the b, which would have to be in front of the x, or there's your h right there, right? So you're really looking to see, am I outside the grouping symbols or am I inside the grouping symbols within that function notation? So in part A, we have the function -1. So that means we would be shifting down 1. It's a vertical shift down 1. So if we were to plot those points here, you can see if I've already generated those critical values. I took them off of the given graph. I listed them here as the parent function. There's no reflection, there's no stretch. The translation means we're going down 1, so the y coordinates are decreasing by 1. So y minus 1 is the operation. Taking each of those y coordinates and decreasing them by 1 is essentially where you end up. So again, to save a little bit of recording time, I've already graphed that. So the orange is the parent function, and the green is the result of shifting it down by 1. Here, in part B, we have the function, and in the grouping symbols, x plus 1. That means that's the value of h. Change it in our head. That would be a left movement of 1. So you can see that's what we have here in part B. If we're moving it leftward, that means we're shifting it to the left. That's changing the x coordinates. So the x values are decreasing by 1. So each of those x are 1 smaller now. You can see that's the graph being shifted left 1 space. Here in part C, you can see we're shifting it to the right 1 space. Each of our x coordinates are increasing by 1, and that's what we see here in the function notation. So f of x minus 1, we're moving it to the right 1 space. So let's look at these others here, then we'll go to the graph as their graphs are on the next page. So now we have a negative on the outside, and we have this negative 2 on the inside. So we have a reflection. That's an upside down reflection, so it's going to be over the x-axis, as well as a right movement of 2 spaces. Now we have a negative inside the grouping symbol, so that's the value of b, right? So here that was the a, this is the b, so the b is a negative 1, so it's a reflection side to side, so it'll be a reflection over the y-axis. Now compare part f and g. This is interesting because we have an a of 1/2, and here's a value of b of 2, right? So the b is the tricky one. So let's see what's going on with each of these. The a is our stretch or shrink. That's obviously less than 1, so it'll be getting shorter. So that is a vertical shrink of 1/2. And then when we have the value of b, right, so b is 2, but when I'm trying to determine how does that change the horizontal width, it's not 2 times wider. We have a horizontal shrink of 1 over b, so 1 over 2. So it ends up we have the same fraction in both cases, but the vertical shrink is affecting the height specifically, and this horizontal shrinking is affecting the width. So let's take a look at those graphs on the next page, just so for a quick reference. So here is part D. There are the critical values that we started off with. We reflected it upside down over the x-axis. Because it's upside down, all of my positive y's are now negative, and vice versa. Negative y's are now positive. And then we moved it right 2 spaces, so my x coordinates increased by 2. So there's the parent function. We flip it upside down and then move it to the right 2, and that's the end result. Here in part E, we only had a reflection side to side, so we're negating the x coordinates. So my positive x's are now negative, and vice versa. Here's the example of 1/2 the height. This is part F. We had a value of a of 1/2. So we're taking the y coordinates, multiplying it by 1/2. And so you can see the width stays the same, but the height is decreasing. Each point is getting closer to the x-axis. And then lastly here for part G, now we're changing the width. So we are half of the width of the original. So there's my original critical values, and each of the x coordinates are being divided by 2. So you can see that the height stays the same, but now my width is being compressed. So the distance of each point is getting closer to the y-axis. And then here's the final example. This is similar to what we were doing already, identifying the reflection, stretch, and translate. It's similar to problems 7, 8, and 9, just a few different numbers. Again, we're taking a look at the fact that this is not in the right format. We don't want a negative on the x, we want a positive x. We're factoring out a -1. That means we're creating an x minus 1 in that grouping symbol. So we have a vertical stretch of 2. We have a movement of right 1 and up 4, and that negative sign is telling us we do have a reflection side to side, so that'll be over the y-axis.